Welcome back 10th standard. The next question that we are going to do is question number 4th from exercise 11.2. Draw a pair of tangents to a circle of radius 5 centimeters which are inclined to each other at an angle of 60 degrees. There are two things given to you. There is a circle of radius 5 centimeters. You need to draw a pair of tangents to that circle, and the tangents are inclined to each other at an angle of 60 degree. So this angle will be formed at the external point from where the tangents have been drawn. The property that we will use to begin our construction is that if we draw radii through the point of contact, those radii are inclined to each other at an angle which is the supplement of this angle at which the tangents are inclined to each other. So if I had to roughly draw a figure, if I have a circle, let's say its center is O and there are two tangents drawn from a point P and the tangents are inclined at an angle 60 degrees. Let's say the points of contact are Q and R. What can I observe or what do I know about this is that if I draw radii from these points of contact, so if I draw radius from point Q and radius from point R, then the angle formed here at the center, the angle at which the radii are inclined, this is supplement of angle at which the tangents are inclined. So angle QOR plus angle QPR. This is 180 degrees. From here we can find out that angle QOR comes out to be 120 degrees. This is the property with which I will complete my construction. I am going to draw a circle with radius 5 centimeters. Then I'm going to construct two radii in such a way that they are inclined to each other at 120 degrees. Further, I will be constructing perpendiculars at the endpoints of the radii. So I will be constructing 90-degree angle at point Q, 90-degree angle at point R. The line segments constructed perpendicular to the radii will meet at a point and that point will be point P. Let's do this. So the first thing I want to do is I want to draw a circle of radius 5 centimeters. And then I want to draw one radius as such. Let's change the angle a bit. Let's name the center as O, this radius be OR, and now I want to draw another radius which will make an angle of 120 degrees with OR. So this point will give me 120 degrees. I actually went ahead and constructed 90 degrees, which is not required. I just need 120 degrees. Let's use a ruler and finish the construction for the radii. So these two radii are inclined to each other at 120 degrees. Now I want to construct perpendiculars at the endpoints of these two radii. Let's draw at the endpoint R. So right through point R, draw a perpendicular. So the angle formed at this point is 90 degrees. Similar thing is to be done from point Q. Let's construct a perpendicular at Q. This is the perpendicular at Q. The angle formed is 90 degrees. The point of intersection for these two tangents will be the external point from which the tangents have been drawn. So the point of intersection here can be named as P, and the angle formed here will be 60 degrees. And you can verify with your protractor that the angle formed here is 60 degrees. The property that we used to start this construction was that the angle at which the radii are inclined, the radii through the points of contact, is supplementary to the angle at which the tangents are inclined. So if PQ and PR are tangents from P to the circle with center O at points Q and R respectively, then angle QOR plus angle QPR is equal to 180 degrees. And angle QOR can be evaluated from here, which was used to construct the tangents.